Hi, this is Manoj Yadav and you are watching Mechanotherapy. So today we will discuss some problems related to continuity equation. As all of you know that continuity equation is based on the mass conservation principle, that is mass can neither be created nor be destroyed, it remains constant. So continuity equation says that rho 1 A1 V1 equal to rho 2 A2 V2, and if the fluid is incompressible then density remains constant. So the equation becomes A1 V1 equal to A2 V2, where A1 and A2 are the areas and V1 and V2 are the velocities. So let's see question number 1. Water flows through a pipe of diameter 20 centimeter at the speed of 1 meter per second. What should be the diameter of nozzle if water is to be immersed at 4 meter per second speed? So in this question you can see that initial diameter and initial velocity are given as 20 centimeter and 1 meter per second, and final velocity is given as 4 meter per second. You have to calculate the new diameter. So we can use the formula A1 V1 equal to A2 V2. Now area for the circular pipe is pi by 4 D1 square multiplied by V1 equal to pi by 4 D2 square multiplied by V2. Pi by 4 will be cancelled out, so we can write D1 square V1 equal to D2 square V2. So D2 square equal to D1 square V1 upon V2. We will convert diameter into meter from centimeters, so it will be 0.2 meter. So D2 square equal to 0.2 square multiplied by 1 divided by 4, that is 0. D2 equal to 0.1 meter. So in this way we can find out the diameter. Now let's see question number 2. A patient who is recovering from surgery is given fluid intravenously. Fluid has a density of 1030 kg per meter cube and 9.5 into 10 power minus 4 meter cube of it flows into patient every 6 hours. Find the mass flow rate in kilogram per second. Now you know mass equal to density into volume. So mass flow rate equal to mass upon time, that is equal to density into volume upon time. This volume upon time is known as discharge Q. Okay, so we can say Q equal to mass upon time. First of all, we will calculate mass in this problem. Mass equal to density multiplied by volume. Density is given as 1030 kg per meter cube and multiplied by volume, which is given as 9.5 into 10 power minus 4 meter cube. So we will get the mass as 9785 into 10 power minus 4 kilogram. Now once we have calculated the mass, we can use the formula discharge Q equal to mass upon time. That is 9784 into 10 power minus 4 divided by 6 into 60 into 60. Since 6 hours is given, so we will convert these 6 hours into 6 into 60 into 60 seconds. So the answer will be 4.5 into 10 power minus 5 kilogram per second. In this way, we will find out the value of mass flow rate or discharge. Now let's see question number 3. A liquid flows through a pipe with a diameter of 10 centimeter at 9 centimeter per second velocity. So initial diameter and initial velocity is given. If diameter of pipe decreases to 6 meter per second, that is new D2 is given, what is new velocity of liquid? So we can directly use formula A1 V1 equal to A2 V2. For circular pipe, A1 is pi R1 square into V1 equal to pi R2 square into V2. R1 square V1 equal to R2 square V2. Put all the values, R1 square means 5 square into 9 equal to 3 square into V2. So we will get V2 equal to 25 centimeter per second. Now let's see question number 4. A horizontal pipe narrows from a radius of 0.25 meter to 0.1 meter. Okay, so the radius is reduced from 0.25 meter to 0.1 meter. If the speed of water in larger radius pipe is 1 meter per second, find the speed in smaller pipe. So we can use A1 V1 equal to A2 V2, pi R1 square V1 equal to pi R2 square V2, pi will be cancelled out, so R1 square V1 equal to R2 square V2. R1 is given as 0.25 meter, so 0.25 into 0.25 into 1, initial velocity for larger pipe is given as 1 meter per second. So 0.25 into 0.25 into 1 equal to 0.1 into 0.1 into V2. In this way we can find out V2 as 6.25 meter per second. Now let's see the last question. A 25 centimeter diameter pipe carries oil of specific gravity 0.9 at 3 meter per second. At another section diameter is 20 centimeter. Find the velocity at this section and mass flow rate of oil. So for finding out the velocity at other section, we can use equation A1 V1 equal to A2 V2, pi by 4 D1 square V1 equal to pi by 4 D2 square V2. So D1 square V1 equal to D2 square V2. D1 is given as 0.25 meter and D2 is given as 0.2 meter. So 0.25 into 0.25 into 3 equal to 0.2 into 0.2 into V2. So in this way we can calculate V2 as 4.68 meter per second. Now you have also to calculate the mass flow rate, that is discharge Q. So you know mass flow rate Q equal to rho 1 A1 V1 or rho A V1. Rho is the density of the fluid. In this question specific gravity is given as 0.9. So density will be specific gravity multiplied by density of ideal liquid, that is water, which is 1000. So 0.9 into 1000, that is 900 kilogram per meter cube will be the density of this liquid. So put 900 in place of rho into A1, that is pi by 4 into 0.25 square into V1, that is 3 meter per second. So in this way we can calculate the mass flow rate as 132.23 kilogram per second. So this is all about the problems related to this continuity equation. I hope you must have learnt a lot from this lecture. Thank you very much.